All right, I'm going to go over how to rewrite equations into slope-intercept form. Before we go into step-by-step like examples, I wanted to go over a few different things really quick. First thing, what is slope-intercept form? Great question. Slope-intercept form is what you see right here. Y equals mx plus b. Now, this means that it's going to be a linear equation. And what does that mean, Miss Monson? It means it will be a straight line. Straight line. Okay. So we want to basically, if you look at number 2 here, we want to rearrange any equation we're given to get y by itself on one side of the equation. So that's our goal. We want y by itself. No matter what equation we're given, we want to rearrange so y is on one side of the equation, everything else will be on the other. So how exactly do we do that? We use inverse operations to move terms from one side of the equation to the other. Now, one key thing here I want to point out, when you are doing this, when we are doing this, whatever you do to one side of the equation, let's say to get rid of a term, you have to do it to the other. So you have to keep the balance in the force. Young Padawan, keep the balance. Okay, showing my nerd side here. All right, what are inverse operations though? Inverse operations, basically we're just talking about what will cancel each other out. So if you have something that's being added, something that's positive, the negative or subtracting it will cancel it out. Same with multiplication. If we have multiplication, the operation that will cancel it out will be division. And you can do it vice versa, right? So if we have division, multiplication will cancel it out. Same with adding and subtracting. If we have something that's negative or something that's being subtracted, the opposite of that would be adding, right? So it can go both ways. I've heard it both ways. All the psych fans. Now that you've heard my lovely singing voice, let's move on. One quick note. When we're solving for a variable, again, that just means we're trying to isolate it on one side of the equation, so get y equals something. We use PEMDAS backwards. So essentially what that means is take a look at what's happening to y. That's what I always tell my students, my kids. What's happening to y? And if you're not totally sure, what I would suggest is actually just like read the equation. Read equation out loud. Now you may feel like super awkward about it, but I promise it helps. So when we're solving for a variable, use PEMDAS backwards, as my lovely students call it, SADMEP. So let's go over an example now. So our first example, we have rewrite the equation into slope-intercept form, and our equation that we're given is 3y minus 8x equals -9. I'm going to use purple on this one. Okay, so again, keep in mind, our goal is to get y isolated. Okay, so I'm going to look what's happening to y. And then do the opposite, inverse operations. So if we were to read this equation out loud, so this is what I mean by reading it out loud, I would say 3 times y, so there we've got multiplication, 3 times y minus 8 times x, so here we have another multiplication going on, multiplication, there we go, equals -9. So invisible math, can't talk, invisible math, this 3 is positive. Okay, and this 8 right here would be negative. Okay, just want to point those crucial things out. Okay, so let's do, I'm gonna stay with purple. Actually, no, let's change it. We're gonna do green. Ninja Turtle colors here, purple and green. Okay, so we want to isolate y. So what is happening to y? We've got multiplication going on. We have subtraction of this term and multiplication in that term. So what I want to do, again, we want to do SADMEP backwards. So any term that is being subtracted or added to the y term, I'm going to get rid of first. So in this case, 8x is being subtracted from 3y. So we want to get rid of that term first. Again, we're going to use inverse operations. So since it's being subtracted, right, we're going to add 8x to both sides. So we're going to add 8x over here. Again, keep the balance, young Padawan. We'll add 8x onto this side too. So what we end up with here, if we have a negative 8x and we add 8x, we end up with 0x, right? And 0 times anything is just going to be 0. So effectively, that just cancels out. And we are left with 3y equals negative 9 plus 8x. Okay, so now we still want to get y by itself, but we have one more thing happening to it. I'm going to switch colors one more time. We still have that multiplication happening. So we have 3 times y equals negative 9 plus 8x. So to get rid of that 3, since we want y by itself, and it's being multiplied right now, I'm going to do the opposite and divide by 3. And if I divide by 3 over here, again, I have to divide by 3 over here. So when we do that, 3 divided by 3 gives us 1y, which is the same thing as just saying y. So we're going to end up with y over here. Now this side's a little more tricky. Okay, I'm going to show you something real quick in a different color so we don't all get confused. We could actually break this part down into 2 separate fractions or division terms. So saying negative 9 plus 8x over 3 is actually the same thing as saying negative 9 over 3 plus 8x over 3. And the reason it's the same is if you have common denominators in fractions, right, you can add them. So saying these 2 terms separately is the same thing as saying them together. Okay, so in this case, now I'm going to simplify where I can. So we have negative 9 over 3, so negative 9 divided by 3. This works out nicely for us, and we are left with negative 3 there. So we have negative 3 plus, here 8 divided by 3 gives us a funky decimal, so I'm just going to leave it as 8 over 3 x. Ooh, look at that! We are basically in slope-intercept form. The only difference between this equation and slope-intercept form is switching the order over here. So because we can rearrange what we're adding and it won't make a difference, mathematical rules, I can also write this equation as y equals 8/3 x minus 3, and there's our equation. So we rewrote this lovely mess into this beautiful slope-intercept form. Okay, I'm going to go over one more example. This one looks a little more hairy. Okay, so in this example, again, we're rewriting the equation into slope-intercept form, but we're starting out with something that looks a little different than our last one. Okay, so I'm going to highlight again our steps or our goals here. The goal is to get, that's supposed to be an A. Goal is to isolate y on one side of the equation. Okay, so again, we're going to be using SADMEP, or PEMDAS backwards. SADMEP. My kids like to call it SADMEP. Okay, SADMEP. So we're going to look at what's happening to y. I'm going to first read this lovely equation out loud. 2 times x, so we have multiplication here. Oops, that is also a positive 2, so it's being added. Positive 2x minus 3 times y, so another multiplication, and we have a subtraction, plus 7, so we're adding, equals 4 times x, multiplication there, minus 8. All right, so we have all of our operations lined up. Again, we're going to undo any term that's being added or subtracted first, okay? Any term that's being added or subtracted to the y term, okay? So, first thing, should we go Christmas colors? Sure, why not? First thing we're going to do, we want to get all the other terms on this side of the equation, that is not the y term, away from that y term. So move it to the other side. I'm going to start with this plus 7. Since it's being added, the opposite or the inverse operation would be subtract 7. And again, keep the balance. So if you subtract 7 over there, we have to subtract 7 on this side of the equation. Okay, so positive 7 minus 7 would equal 0. So effectively that just cancels out. And we'd be left with 2x minus 3y equals 4x. Now I could write 4x minus 8 minus 7, but because these are like terms, I'm just going to combine them from the get-go. Negative 8 minus 7 is going to get us negative 15. Okay. Now we need to move this this x term away from the y term. So because that 2 is positive, to get rid of it, we're going to do the opposite. We're going to subtract. So subtract 2x from this side, which means we also have to subtract 2x on this side of the equation. Okay, now positive 2x minus 2x is going to equal 0. It cancels each other out. All right, so on this side, we are left with negative 3y. We're getting close. Equals, and again, because these are like terms, I'm going to actually combine them from the get-go. So 4x minus 2x leaves us with 2x minus 15. Okay, one more step, you guys. We want to get y by itself. Right now, it is being multiplied by negative 3. So to undo that multiplication, we're going to do the inverse operation, or the opposite thing, which is divide. So we're going to divide by negative 3. Keep in mind you have to keep that negative, the negative with the 3, or you're going to have an extra step. Okay, so divide by negative 3, which means we have to divide by negative 3 over here. Okay, so negative 3 divided by negative 3, that's going to, that is going to equal 1. So essentially that would equal 1y, but that's the same thing as just saying y. So we have y equals, now again, over here, we can essentially just split these terms up like we did before. Keep in mind you have to keep that negative there, okay? Over here, we have 2 divided by negative 3. That gives us a funky decimal again, so I'm just going to keep it in fraction form. Make sure I keep that negative. Negative 2/3 x. And here, just to point this out, we have a negative 15 divided by negative 3. So keep those negatives, you guys. A negative divided by a negative is going to equal a positive 5. Okay, so on our equation, we would have plus 5. So we went from this hairy mess to this not so hairy mess. All right, we're in slope-intercept form now. I hope those examples help. If you have questions about this, let me know in the comments.